In number 21, we have another system of equations, and we want to multiply both sides of one or more equations by a number, and with the object of being able to add the equations together and have a column, either x column or y column, canceling. So first let's decide which column we want to cancel, or which variable we want to eliminate. Well, since the y-coordinates already have opposite signs, maybe I'll stick to the y-coordinates. And I want to multiply top and bottom. I want to multiply the first equation, and I want to multiply the second equation, so that we end up with something here that will cancel. Well, we need to end up with something that 2 divides into and 3 divides into, so that would be 6. All right, so if we multiply this equation by 3, and this equation by 2, see this time in the last example we were able to only do one multiplication, only multiply one equation, but this time we have to multiply both equations in order to eliminate our y variable. So we're going to get a minus 6 here after the multiplication, and we're going to get a 6 here, and that'll work. Okay, so let's multiply and rewrite. So here we have 9x minus 6y is equal to minus 24. In the second equation, we have 10x plus 6y is equal to minus 14. All right, this is 19x. Here we have our canceling. And here we have minus 38. And now let's divide by 19. And this goes in evenly 2 times. So we have x is equal to negative 2. And now to find y, we'll substitute in x equal minus 2 into the top equation. You could use the bottom or the top, but I'll use the top. So we have 3 times minus 2 minus 2y is equal to negative 8. All right, so that's minus 6 minus 2y is equal to negative 8. All right, add 6 to both sides. And we have minus 2y is equal to minus 2. And just divide by minus 2, and we have y is equal to 1. So our solution would be the pair of numbers, x equal minus 2, y equal 1. We could write them as a pair of minus 2, 1 in point form. And now let me show you how to do a check. Well, if we check, we have to substitute into both equations. So first, we want to substitute in minus 2, 1, let's say into the first equation. So we want to see, is 3 times minus 2 times 1, is that equal to negative 8? All right, so that is minus 6 minus 2 is equal to negative 8, so that one checks. And now let's substitute into the second equation. So we want to see if 5 times minus 2 plus 3 times 1 is equal to negative 7. That is, minus 10 plus 3 is equal to negative 7, so that works as well. So our solution does check. In number 22, we have a function, and this reads f of x. Let me just write down how to read that. F of x. F of x is equal to 2 minus 3x over x squared plus 1, and we want to find f of minus 2. So basically this just means sub in x is equal to minus 2. That's all we have to do here. So on the left-hand side, we write f of minus 2, replacing x with minus 2. And on the right-hand side, do the same thing, just replace x with minus 2. So in the numerator we have 2 plus 6. And here we have 4 plus 1. So we get 8 over 5. So that's f of minus 2 is 8 over 5. And basically, this just means that when x is equal to minus 2, this expression is equal to 8 over 5. In number 23, we're asked to find the domain of our function. Now, we can think of the domain as all possible x values that we can substitute in to this expression and come up with a y value, or with a, with that this has to be equal to something when we substitute in a particular x value. All right, so here, this expression has a denominator, so we know that we can't substitute in x values that make the denominator 0, or if we do, then this won't be a real number. So when is this denominator 0? Well, we can only figure that out by factoring the denominator. So let's do that. Let's factor this. We have a quadratic in the denominator. Okay, so we're going to factor it. One's positive, one's negative, and we want to get a plus 3 in the middle. So we'll go with 5 times 2 minus 5 plus 2. Let's just check that that works. Here we have, sorry, actually it doesn't work. We need a plus 3 in the middle, so we're going to go with a plus 5. Let me erase this. And, okay, and a minus 2. All right, let's check that that works. So we have 5x and a minus 2x, that's a plus 3x. So we see from the way this denominator factors that if x is equal to 2, for example, the denominator will be 0, and this won't be a real number. Or if x is equal to minus 5, again the denominator will be 0. So we can substitute in anything except for those two values. We have to avoid minus 2 and avoid 2 and avoid minus 5. So we write the domain as follows. Okay, this is our domain, capital X meaning all x values, except x cannot equal to minus 5 and x cannot equal to 2. All right, let's look at part B. All right, here we have a function that has a square root. Now we know that whatever is underneath the square root must be kept greater than or equal to 0, because the square root of a number that's less than 0 is not a real number. So we want to make sure that 2 minus 5x is greater than or equal to 0. So let's just write that down. So we just have this little inequality which we're going to solve, and that'll give us our domain. All right, let's divide by minus 5. Don't forget to switch this direction. All right. So we have x less than or equal to 2/5. So that's actually our domain. Sometimes it might be written like this, or sometimes it just might be written like this, x less than or equal to 2/5. Okay, finally we have a square root. In C we have f of x is equal to 1 over the square root of x minus 5, so we have a square root, and we have a denominator. All right, so for that reason we have to make sure that whatever is in here, not only does it have to be greater than or equal to 0, but actually we have to make sure that it's greater than 0. In other words, we want to eliminate 0 as well. Okay, in the above example, we could take the square root of 0. square root of 0 is equal to 0. But we don't want 0 in the denominator, so here we want to make sure that underneath the square root we have something that's not 0 and positive, so that means greater than 0. So we just write down our little inequality. X minus 5 now has to be greater than 0 rather than greater than or equal to. And just add 5 to both sides, and our domain is x greater than 5. Okay, so this ends our review for test 4. So if you haven't done so already, then try to do these problems on your own. You can get a copy of these problems, a copy of this template on mathbreeze.com. And you also have the other review sheet for test 4 on mathbreeze.com, so you should do that one as well. So you have plenty of problems to work with. These two review sheets and the homework problems, and watch the video. Make sure you know how to do everything, and then I'm sure you'll do very well. Okay, so good luck with your studying.